Welcome my dear students. Today we are going to discuss some other kind of different types of functions which are very essential for our continuation of functions topic. That is what means number one is one function like this. One function. Okay, another name given to this is also injection. This is what? Injection. Another name given to that is injection. One function. Another name for this is injection. What is the definition of this one function? Means no two elements in the domain. No two elements in the domain. Okay, in the domain got the same image. No two elements in the domain got the same image. Right? This is what that means. Okay, no two elements in the domain got the same image. That means different elements in the domain will have different images. Like different elements in the domain has different images like this. Different images. Right, my dear students? This is what we have here. Different elements in the domain has different images. Right? Fine. Now we will going to explain this with some different kinds of examples. Like suppose I am having set A. This is what set B, like this. Set A and set B. Right? When I am having set A and set B, here I am having something like 1, 2, 3, 4 like this. Right? I am having A, B, C like this. 1 with A, 2 with B, 3 with C, 4 with C. Is it a one function? No, it is not a one function because 3 is corresponding with C and 4 also corresponded with C. Therefore, 3 and 4 both have the same image. That's why it is not one function. It is not a one function like this. Okay. I told you that no two elements in the domain got the same image. That means different elements in the domain should have different images. That's why, my dear students, this is not a one function like this. Next, let us see that. Right, I am having here suppose 1, 2, 3. Okay, A, B, C like this. 1 with C, 3 with A, 2 with B. Is it a one function now? Please observe. Is it a one function? Yes. It is a one function because different elements got correspondence with different images. Therefore, it is a one function. No doubt in it like this. Right? This is an example of a one function. We are going to discuss more in depth in these one functions. You are going to get in competitive examinations, right? Which is one function, which is not like that. We are going to have many kind of problems. Those all we are going to answer in this, right? Now we have here 1, 2 and this is A, B, C, D like this, right? Now we need one functions. How many? This is now 1 with B, 2 with C. This is one type of one function, like and another thing you have here something like 1, 2, A, B, C, D like this. 1 with C, 2 with D. This is another type of one function. And we have another thing like this. 1, 2, A, B, C, D like this. 1 with A, 2 with B. This is another type of one function like this. Like that we will have, okay, how many one functions we are going to have, that also we are going to discuss. Like here 1, 2, A, B, C, D like this. 1 with D, 2 with A like this. Print, okay, like this we are going to have many different types of one functions. What are those? All we are going to present and we are going to discuss in depth of this thing. This is very important for a JEE Mains point of view, right? Now see, suppose we have now, suppose f is a function from A to B. F is a function from A to B like this, right? We have here three cases we have here, of course, right? What are the three cases means? So suppose we have here that n of A is greater than n of B like this. N of A is greater than n of B. Then number of one functions are how many means? Just by an example I am going to tell you. 1, 2, 3, 4. I told you that this set A is having 4 elements, set B is having 3 elements. Number of one functions are going to be how many here? 1 with A, 2 with B, 3 with C, 4 with some other element it should map. Suppose it should be a function means. Then it is not a 1-1 function. Therefore, when n of a is greater than n of b, number of 1-1 functions, number of 1-1 functions, okay, number of injections, otherwise number of 1-1 functions is equal to 0. When n of a is greater than n of b, the number of 1-1 functions becomes 0. Okay, this is what case 1 we are having like this, right? Case 2 we have when n of a equal to n of b, right? N of a is equal to n of b. Then number of 1-1 functions. How many we are going to have that? Okay. In this case, you are going to get number of 1-1 functions. This is 1, 2. I am having here a, b. Suppose I am having like this. 1 with a, 2 with b. Here like this. Right. This is one function like and another thing. Okay. You have here 1, 2, a, b like this. 1 with b, 2 with a. These are two functions we have got here. Suppose a and b like this. And what is the generalized formula for this means? Right, when it is equal, like when it is equal, suppose n of a equal to n of b is equal to, suppose you take it as some n like this. Then number of 1-1 function, number of 1-1 functions, 1-1 functions when n of a is equal to n of b, this is equal to n number of elements, then that is nothing but n factorial. Okay, n factorial. N factorial means here 2 factorial, that means two functions we have got here like this. When n of a equal to n of b, then number of 1-1 functions is given by n factorial. That means, okay, product of first n natural numbers, right? Now the third case, when we have here n of a less than n of b, then we are going to discuss now number of 1-1 functions, what are they. Now case 3, when n of a is less than n of b, okay, suppose let us take that n of a is equal to n and right, n of b is equal to some r elements are there like this, right? Okay, fine. When n of a is equal to, here in this case n of a less than n of b, let us take that n of a is equal to some number, anything like that. Okay, some m we will take here like this, and n of b is equal to some n we will take like this, right? Once we take the thing like this, what we are going to have, the number of 1-1 functions are nothing but npm like this. Okay, npm, the number of 1-1 functions are nothing but npm, right? See here, this is what we have here, npm. Like npm means actually, you know, n factorial by n minus m factorial like this, right? Fine, this is equal to np, right, n factorial by n minus m factorial like this. We have here like this, fine. In this case, for example, if we think like this, we have here 1, 2 and this is what a, b, c like this. 1 with a, 2 with b like this. We have here and 1, 2, a, b, c. Here also this is a, b. N of a is less than n of b. Then number of 1-1 functions what we are going to have. 1 with b, 2 with c. Here like this we have here, and next we have here 1, 2, a, b, c like this. Right, we have here something like 1 with b, 2 with a also may have like this different functions. Now in this case what we have here, n of a is equal to 2, n of b is equal to 3. That means 3p2 like this. 3 factorial by 3 minus 2 factorial, 3 factorial by 1 factorial. That means 6. Okay, 6 1-1 functions we are going to have in this, of course. 6 1-1 functions we are going to have, okay, like this. These are now 3 we have got. Next one, 1, 2, a, b, c. If we have like this, 1 with c we may have here like this. Another one with 2 with a we may have like this. This is another kind of function. Okay, next this is one more thing like 1, 2, a, b, c like that. We can have like different kinds of functions like, you see, fine. Okay, 1 with c and 2 with b, like 1 with c and 2 with b like this. 1 with c, 2 with b, right? This is also you are having here, fine. Next 1, 2, a, b, c like this. 1, 2, a, b, c like that. That means here Fine. We have one more thing like this. One more thing we will have. Okay. Yeah. We'll have one more function like this. Totally here 1, 2, 3, 4, and the other one what we are going to get. This is now 1a, 2c. This is now totally 6 functions we are having here, of course. Now, actually we have one formula, that is the formula NPR is nothing but n factorial by n minus r factorial. This is the formula, permutations formula. Using this, we are going to get a number of 1 functions. That is what I have told you. NPM means n factorial by n minus m factorial, like this, right? Fine. Now, let us check some problems which are 1 functions or not. Suppose there is one problem, f is a function from real numbers to real numbers. And they have given that f of x is equal to x square. Verify whether it is a 1 function or not, right? Verify whether it is, right? Whether it is injection or not, like this. Injection or not. Okay? Fine. You see, Nana, how we are going to do this particular problem is, right? When we have the thing like this, right? Verify whether it is an injection or not means, in the sense, for example, you see here how this is going to be. This is real numbers and this is real numbers I am having here. Suppose I take 1, this become 1 square, become 1. Minus 1, if I take minus 1 square, also 1. Because the rule is f of x equal to x square, right? You know that f of 1 is equal to 1 square, that is 1. F of minus 1 also, minus 1 square, that is 1. And 2 will be related with 4, because f of 2 equal to 2 square, 4. And minus 2 also related with 4, because 2 different elements have same image. Therefore, it is not a 1 function. This is not a 1 function. Like this, we are going to check whether it is a 1 function or not. Now, second example, suppose if I replace instead of real numbers, natural numbers to real numbers. Natural numbers to real numbers. And the rule is f of x is equal to x square. Okay, verify whether it is 1 or not. Whether it is 1 or not, like this. Right? Here in this case, what we are going to have here, okay, of course, this is now natural numbers and this is nothing but what we have here, real numbers. We have here 1, 2, 3, 4, so on up to infinity. And here also minus infinity, so on up to plus infinity we have here, of course. Right? F of x equal to x square. That means 1 square with 1, 2 square with 4 we have here, 3 square with 9 we will have here, like this. Therefore, it is a 1 function here. It is a 1 function. It is an injection in this case, because the domain is set of all natural numbers. That's why this is a 1 function, like this. Next, one more example we are going to discuss. For example, f is a function from real numbers to real numbers I am going to have. And f of x is equal to, right, x cube. What about this? X cube. F of x equal to x cube. What about this? Is it a 1 function or not? Like, now we take here, this is real numbers, this is also real numbers. Okay, yeah, minus, okay, this is from minus infinity to plus infinity. This is also from minus infinity to plus infinity we are going to have. And minus 1 cube is become minus 1. And 1 cube become 1, like this. Okay, it is what? F of x equal to x cube. Now, different elements will have different images. Therefore, it is a 1 function, no doubt in it, of course. Right? This is a different function, minus 1 cube. Here you see, Nana, f of minus 1 is equal to minus 1 cube, that is minus 1. F of 1 is equal to 1 cube, that is 1. F of 2 cube, okay, f of 2 is equal to 2 cube, that is equal to 8. F of minus 2 equal to minus 2 cube, that is minus 8. That means what you are having, different elements will have different images. Therefore, f is a function from real numbers to real numbers. And f of x is equal to x cube is a 1 function, no doubt in it, right? Now see here, my dear students, f is a function from real numbers to real numbers, and f of x is equal to sin x. Okay, f of x is equal to sin x. Whether it is a 1 function or not, if you check. You know, my dear students, f of 0 is equal to 0, f of pi also 0. Okay, f of 0 equal to, see how we are going to do. Sin 0 is 0, f of pi, that means sin pi is also 0, like this. And f of 2 pi, like this. So this is also sin 2 pi, sin 360 degrees also 0. That means different elements you see here, 0, pi, 2 pi, like that. They are all mapping with 0, pi with 0, 2 pi with 0, like this. Because this is real numbers and this is real numbers, and the rule is nothing but f of x is equal to sine x, like this. F of x equal to sine x. Therefore, it is not a one-one function. F of x, all trigonometric functions, if you take here, for example, even for okay, f is a function from real numbers to real numbers. F of x is equal to cos x. This is also not a one-one function. Cos x. Why means here also, my dear students, you can understand that, right? Okay, we have here like this f of 0, okay, is equal to 1, like this. Why 1? Because cos 0 is 1, like, right? And f of 2 pi, that is cos 2 pi also 1, like this. Cos 2 pi also 1, like that. And of course f of pi by 2 you take, that is cos pi by 2. Cos pi by 2 is 0. And f of 3 pi by 2, f of 3 pi by 2, that is now cos 3 pi by 2, that is also equal to 0. That means, you see, under this rule what we have here, real numbers to real numbers, even the rule is f of x is equal to cos x. What we can say is, you have here 0, 2 pi, they are all mapping with 0, 0, like this. And pi by 2 and 3 pi by 2, they are all mapping with 0. Okay, sorry, these are all mapping with what, Nana? 1, and these are all mapping with 0, like this. Right, like this, we can say that all trigonometric functions are not one-one functions. We can easily say that all trigonometric functions are not one-one functions. Next, we have graphical testing for one-one functions, my dear students. Here, suppose if we have any graph like this, suppose I am having here f is a function from real numbers to real numbers, and f of x is equal to x square. That means y is equal to x square. This graph, we already observed that this is a upward parabola like this. Upward parabola like this. Right? Is it a one-one function? Okay, the graphical testing for one-one function is what means you have to draw a horizontal line. You have to draw a horizontal line. Whereas to check whether a function or not, there is a testing. What is that? Vertical line test. For checking injection. Injection means one-one function. It is the testing of horizontal line. Horizontal line test. Like this. That means we have here now, okay, the logic is here. Suppose I am having here one x1 value here, of course, and this is what this height is nothing but, let us make that this is some y1 like this. Therefore this point is x1 comma y1 we have here like this. Here you have x2 and this height is what? Y1. Therefore that point is nothing but x2 comma y1. Two different elements x1 and x2 are corresponded with same y element. That means, see here, if you take here, x1 is corresponded with y1 and x2 also corresponded with y1. Two different elements have same image. Therefore, whenever you draw a horizontal line, if it cuts the curve at more than one point, then it is not a one-one function. Then it is not a one-one function. This is the graphical testing for one-one function. For example, if I have, right, a function is like this, right, I am having here f of x is equal to something like x cube will be like this. Is it a one-one function? Means yes, anywhere if I draw horizontal line, it cuts the curve at single point. Here also it cuts the curve at single point. Therefore it is a one-one function. This is a one-one function, whereas this is not a one-one function, right? Now let us take one more example. F is a function from real numbers to real numbers, and f of x is equal to, let us take right, any one okay, a quadratic equation, x square minus 5x plus 6. What about this? Is it a one-one function or not? Suppose you see here the graph of this is, its roots, you know, my dear students, these roots are 2 comma 3. Therefore if you plot the graph will be like this. Is it a one-one function? You can easily say that it is not a one-one function, because whenever you draw a horizontal line, or here f of 2 value is equal to 0 and f of 3 also equal to 0, because they are the roots. Now 2 and 3 have got the same image. 2, 3 got the same image. 2 with 0, 3 with 0 we are having like this. Therefore, okay, f of 2 is 0, f of 3 is 0. They have got the same image. That's why they are not, this is not a 1-1 function. Like this you can verify plenty of examples. Next we have another function called onto function. This is a very important 1-1 function. Next one is onto function. Another name for the onto function is surjection. It is called as a surjection. Like what is the definition of that is each and every element in the codomain, each and every element in the codomain has at least one pre-image, like this, one pre-image. This is what the definition of onto function or surjection. Otherwise, this also we can say that if range is equal to codomain, then we can say that it is precisely the shortcut way of defining. The shortcut way of defining is if range is equal to codomain, then it is a onto function, right? If range equal to codomain, then also we can say it is an onto function. You see, for example, we have here with a basic example, let us try to check. This is A, B. We have here like this. I am having 1, 2, 3. I am having A, B, C, D like this. 1 with D, 3 with A, 2 with C. Is it an onto function? No. Why it is not an onto function? Means I told that each and every element in the codomain has at least one pre-image. A is having the pre-image as 3. D is having pre-image as 1. C is having the pre-image as 2. But B is not having at all any pre-image. B is not having at all any pre-image. That's why it is, right, is not an onto function like this. It is not an onto function. B is not having any pre-image. Here also you see the range. Range is what? ACD here. The range is equal to, this is what? ACD. And codomain is nothing but what here? Codomain is nothing but ABCD like this. Therefore, range is not equal to codomain here, of course. Range is not equal to codomain. That's why this is not an onto function. This is a precise example what I am giving to you, my dear students. Next, we have something like this. I am having 1, 2, 3. I am having A, B, okay, like this. 1 with A, 2 with A, 3 with A. Is it a onto function? No, here also not onto function, because I told each and every element in the codomain has at least one pre-image. Here A has pre-images 1, 2, 3. At least one they told, but here it is having 3. But B is not at all having pre-image. That's why it is not onto function like this. Now let us think about the other one, okay. I am having here like this 1, 2, 3, A, B like this. 1 with A, 2 with B, 3 with B. Okay, here what about, is it an onto function? Yes, it is an onto function, because A is having pre-image 1, B is having 2, 3. We told at least one. At least one means more than one, no problem. Therefore, it is an onto function like this. This is an onto function, right, my dear students? This is the way how you are going to check. Here also you have got the range is equal to codomain. Range is A, B, codomain also A, B. Therefore, this is the way how you are going to check whether it is an onto function or not, or a surjection or not. Now let us check some examples, so how to verify whether they are onto functions or not. For example, I am having very basic thing. F is a function from real numbers to real numbers. F of x is equal to x square. Verify whether it is an onto function or not. Like verify whether it is an onto function or not. It is an onto function or not, like this. Right? How we are going to get this problem? You see here, my dear students, here of course whenever we have here real numbers, this is also a real numbers like this. Whenever we are having here minus infinity to plus infinity, so on like this, minus 2, minus 1, 0, 1, 2, so on up to infinity like this. Right? The real numbers, x square we have here. Minus 2 will correspond with 4, minus 1 will correspond with 1, 0 will correspond with 0, 1 will correspond with 1, 2 will correspond with 4, like this. Right? Very nice. Then what about here when you have the negative numbers like this? Something negative numbers you will have here, minus 1, minus 2, minus 3. Do they have pre-images? Do they have pre-images? That is the question. That's why how we are going to check whether it is a onto function or not means we are going to take f of x is equal to x square, that is nothing but image. Usually you know that see, whenever we are having a function like this, I'm writing here, if we have x and its image is nothing but f of x, that we are going to write it as y like this. Okay, f of x equal to this, we have now x is equal to root y like this. X is an element of the domain here, this is what domain, and this is y is an element of codomain like this. Y is an element of codomain. In this situation, what they have given that f is a function from real numbers to real numbers. That means x belongs to R and y belongs to R. Both are real numbers. Both are real numbers means now x equal to root y. Okay, y is a real number. If I take see here root over, for every real number I have to get one real number as x. Okay, for every real number y I have to get one real number x. Now if I take negative real numbers, may I find that here x is a real number here. Suppose if I take a negative number minus 3, x equal to root over minus 3, that is nothing but root 3i. It is not a real number. This is not a real number. That does not belong to R. Therefore, this is not an onto function. This is the way how you are going to check. Right? This is not an onto function. For every real number y, I have to find one other real number. That means if I take minus 3 is a real number, but x equal to root over minus 3 is not a real number. Therefore, it is not an onto function. Right? Now, another example, let us take f is a function from real numbers to real numbers and f of x is equal to, let us take 3x plus 5. What about this? Okay, verify whether it is 1, 1 and onto. Right? It is a 1, 1 function, no doubt in it, because if you give different elements from domain, it will give different images. Therefore, it is a 1, 1. Now, okay, verify whether it is onto. Okay, whether it is onto or surjection like this, whether it is onto. You see now how we are going to observe this problem is, as I told you that for range is equal to codomain we are going to have. That means, and another one is for each and every element in the codomain I have to find one okay, pre-image, at least one pre-image. You see how I am going to do this is what the general rule of getting this. Okay, let us take this as y, and you know that f is a function from real numbers to real numbers. X is belongs to R and y also belongs to R. That means you have here 3x is equal to y minus 5. X is equal to y minus 5 by 3 like this. Right? X is equal to y minus 5 by 3. Right? That means you see y is a real number. Y is a real number means for any real number minus 5 by 3. For any real number minus 5 by 3. Right? Right? For any real number minus 5 by 3 is once again a real number or not? Yes. You take any real number minus 5 by 3 is once again a real number. For example, you take y is equal to your wish, anything, 2 by 3, like 2 by 3 minus 5 by 3, like this. Let us see that you take in here y is equal to 2 by 3, like this. Let us simplify this. If you simplify this 3, you have here 2 minus 15 into 1 by 3 here like this. 2 minus 15 become what? Minus 13 by 9. This is also a real number. Therefore, it is an onto function. Okay. Here the logic is, my dear student, you have to take f of x equal to y, 3x equal to y minus x. You have to subject x in terms of y. Then you see that for every y, we will be able to define x. We will be able to define x perfectly. Here now y is a real number means y minus 5 by 3 is also a real number. That's why x is a real number. Therefore, it is an onto function or a surjection. Now see this one, f is the third problem. F is a function from real numbers to real numbers and f of x is equal to sin x. Verify whether it is onto or not like this. Right? You see, my dear students, you know that of course for the sin x, you know the domain and range. When you take minus infinity to plus infinity, whatever it may be, okay, it lies between minus 1 and 1 like this. The domain is nothing but set of all real numbers and the range is nothing but it takes only from minus 1 to 1 like this, right? Minus infinity so on up to minus 2, minus 1, 0, 1, 2, 3 so on like this. and its range is from -1 to 1. From this only we are going to have, of course. Therefore, range is not equal to codomain. Therefore, it is not onto function, not onto function like this. Okay, if you take even cos x also the same thing. F is a function from real numbers to real numbers, and f of x is equal to, if you take cos x, this is also not onto, because cos x range is nothing but -1 to 1 like this, right? Okay, what about tan x? Like f is a function from real numbers to real numbers, and f of x is equal to tan x. Like when you take tan x, okay, the domain actually f is it is not defined at, you have to take out 2n plus 1 times of pi by 2 like this. Okay, you have to take out this 2n minus 1, 2n plus 1 into pi by 2. This is the domain, and the range is real numbers, of course, right? And it becomes tan x when you observe also the graph will be like this. The graph will be like this, right? For every real number will you have a pre-image, means yes, it is an onto function. Similarly for cot x also you will be getting it is an onto function like that. And what about if f is a function from real numbers to real numbers? F of x is equal to cosecant x. Cosecant x, is it a real onto function? Means actually the codomain domain is actually the domain also, if you take here r minus 1 by sin x. 1 by sin x means r minus n pi. We have to take to r like this, right? And you know that cosecant x is having the range is nothing but r minus of -1 to 1. You know that. Therefore, the range is not equal to codomain. Therefore, it is not onto function. Like that, you can check even for secant x also. Now we have this one. F is a function from real numbers to real numbers. F of x equal to mod x. Verify whether it is onto. Means you know that my dear students, here also you can easily observe that these real numbers and real numbers, minus infinity to plus infinity we have here. So on like this, -2, -1, 0, 1, 2, so on up to infinity, right? -2 with 2, -1 with 1 we have here, of course. 0 with 0, 1 with 1, 2 with 2 like this, because okay, f of -2 that is equal to -2, that is modulus of -2 is 2. F of -1, that is modulus of -1 is 1. F of 0, that is 0, right? And f of 2 is modulus of 2, that equal to 2. And f of 1, that is modulus of 1 is equal to 1 like this, right? We have all positive numbers up to infinity like this. But these negative numbers does not have any pre-images. Therefore, it is not onto. Therefore, it is not onto function like this. We will be discussing. Now, we are going to discuss number of onto functions, right? Number of onto functions. Now, case 1 we have here. Okay, case 1. What is case 1? Is when you have here, right, n of a is less than n of b, like, okay, when f is a function from a to b, right? When f is a function from a to b, n of a is less than n of b. For example, let us take a is equal to 1 comma 2, b is equal to some right a b c like this, right? In this case, when we have 1 2 and a b c, 1 with maybe b and 2 with a, this is the possibility. That means here in this case a, b we have here, when n of a is having 2 elements, n of b having 3 elements. In this case it is not at all onto function. Number of onto functions becomes 0. In this case, if n of a is less than n of b, and if f is a function from a to b, then number of onto functions is equal to 0 like this. Number of onto functions becomes 0 because one element will be, some elements will be left in the codomain. They will not have any pre-images. That's why the number of onto functions becomes 0 in this case. Next, case 2, let us take, my dear students, case 2, if you take f is a function from a to b, and we have here n of a is greater than or equal to 2. N of a is greater than or equal to 2, greater than 2, and n of b is having only 2 elements like this. N of a is right, we have here, yeah, greater than or equal to 2, and n of b is equal to 2 elements we are having. Then number of onto functions. Number of onto functions. This is nothing but, right, 2 power n of a minus 2. 2 power n of a minus 2, like this, right? Suppose you have here like 2 power n of a minus 2, right? For example, we have here like a is equal to, you have 1 comma 2, right, and b is also equal to a comma b. Number of onto functions are nothing but what here now I told you that 2 power n of a, that is 2 power 2 minus 2, that means 2 will be having that. Let us observe them. Okay, fine. 1, 2 I am having, a, b I am having. 1 with a, 2 with b. This is one thing. Another one, 1, 2, a, b. 1 with b, 2 with a. These are the two onto functions we are having like this. Okay, when see Nana, f is a function from a to b, n of a greater than or equal to 2 and n of b equal to 2, the number of onto functions is nothing but 2 power n of a minus 2. That a is 1, 2, b is ab, then 2 square minus 2, that equal to 2 functions we are having in this. Now we have the third generalized case is a very important. If f is a function from a to b, n of a domain is having r elements, n of b codomain is having n elements, where n should be greater than or equal to 2, and also the condition is here n of a should greater than or equal to n of b. We answered n of a less than n of b. We answered n of a equal to n of b. This is now n of a greater than or equal to n of b. Then number of onto functions are n power r. N is nothing but number of elements in codomain. R is nothing but number of elements in domain. N power r minus nc1 into n minus 1 whole power r plus nc2 into n minus 2 whole power r minus nc3 into n minus 3 whole power r, so on like this. This is now minus 1 power n minus 1 into nc n minus 1, like this, right? This is the thing we have here. Suppose let us take here that f is a function from a to b, and n of a we have here that right, three elements we have here like that, and n of b is also having 3 elements like, okay, n of a is 3 and n of b also 3, both. Okay, now the formula here, according to the formula we have given that n of a equal to r is equal to 3 we have here like this, and n is equal to 3, that is what n of b we have here like this, right? Now number of onto functions, so number of surjections, because another name for onto function is nothing but surjection. Number of surjections is nothing but n power r. N power r means 3 cube minus, right, this is what, n power nc1. nc1 means what, 3c1 into n minus 1, 3 minus 1 whole power r, this one, plus nc2, that means 3c2, n minus 2, that is 3 minus 2 whole power r, like this, right, minus nc3, that is minus 3c3, n minus 3, that means 3 minus 3 whole power r, like this, 3, like this. There it ends. Now 3 cube equal to 27 minus 3c1 into, this is 2 cube plus 3c2 into 3 minus 2, that is 1 cube minus 0, like this. And my dear students, you should know there is a formula, Ncr formula, that is n factorial by r factorial into n minus r factorial, like this. Suppose I want 3c2 value, this is now 3 factorial by 2 factorial into 3 minus 2 factorial. This is now 3 factorial by 2 factorial, that is 3 into 2 factorial by 2 factorial. This you will get it as 3, like this. Okay, like that we are going to get 27 minus, in this way we are going to get 3c1 value also 3, 3 into 8, that is 24, 8 3 is 24, 3c2 value also 3, like this, 27 plus 3, 30, 30 minus 24, there are 6 surjections you are having totally. See my dear students, this is a generalized formula, it is very important. You are going to use this formula for any case satisfying these conditions like this. F is a function from a to b and n of a equal to r, n of b equal to n, then n of a greater than equal to n of b, then number of onto functions is nothing but n power r minus nc1 into n minus 1 whole power r plus nc2 into n minus 2 whole power r minus nc3 into n minus 3 whole, so on like this. Here One example we have taken here, one example problem, n of a equal to 3, n of b equal to 3. Then number of onto functions we have got by this formula as what? Okay, 30 minus 24, that is 6 functions we have got overall. Like this, my dear students, you please prepare well for the exam. These are all included, right, for JEE mains. Thank you very much.